Hello, in the electric power industry, point-to-point SCADA services are very common. However, in some cases, RTUs need to interact with multiple SCADA controllers. This video will introduce the SCADA point-to-multipoint function by using the point-to-multipoint RS232 service over SRv6 as an example. RS232 is a serial physical interface standard defined by the Electronic Industry Association, the EIA, designed for data transmission using serial interfaces. The traditional RS232 standard used a 25-core D-type connector, DB25, later simplified to a 9-core D-type connector, DB9. Today, it's very common to use these DB9 connectors for RS232 services. The use of 3 signal lines, receive, transmit, and ground lines, achieves a simple 4-duplex communication process. Huawei provides an interface card that supports 2-channel RS232 or 2-channel RS485. Its interface complies with the RJ45 standards. To test the RS232 service, a PC works as an RTU device that has a DB9 RS232 interface. Use a RJ45 to DB9 cable to connect the PC and the service interface card. Then, use the software on the computer to log into the corresponding serial ports for data signal transmission. As shown in the figure, assume that there are 2 RTU devices as well as master and backup SCADA controller centers. Each RTU is required to communicate with the 2 SCADA control centers. To achieve this, we introduce the SCADA group feature. A SCADA group is created on duty 2, and multiple RS232 physical interfaces can be associated with this SCADA group. Create multiple virtual serial interfaces and bind them to the same SCADA group. Create end-to-end PW services between the virtual serial interfaces and the physical interfaces of the remote RTUs. In a SCADA group, the RS232 serial interfaces data can be broadcast to multiple virtual serial interfaces. The virtual serial interfaces data can be filtered and converged to the RS232 serial interface. This is how the point-to-multipoint function is implemented. You can see here the basic test topology and the test procedure. In a lab, PCs serve as RTU and SCADA control servers. Use RJ45 to DB9 cables to connect the PCs to the interface card. Duty 1 connects one PC serial interface. Duty 2 connects to PC serial interface. Now, test the RS232 service over SRv6 to check whether one RTU can communicate with the 2 SCADA servers. First, deploy FlexE network slicing and create 3 slices for all devices. Slice 0 is the default slice, and slice 1 and 2 are service slices. Configure IPv4 and IPv6 addresses on the base slice interface. There is no need to configure IP addresses on other slice interface. Deploy SS to ensure root reachability on the entire network. Check IPv4 and IPv6 routing information on the device. Activate MPLS L2 VPN on duty 1 and duty 2. An LDP session is set up between the two devices. The session status is up. Activate SRv6. Configure locator information. Define segment list to work as primary and backup paths. Create an SRv6 terminal and recurse the terminal to network slice 1. Check the SRv6 policy status on duty 1. The primary and backup paths of the terminal are up and bound to network slice 1. SBFD is used to quickly detect path faults. Hot backup is used to quickly switch traffic to the backup path if the primary path fails. The same results are displayed on duty 2. Now, configure one SCADA group on duty 2. The physical serial interface that connects the master SCADA server is added to the SCADA group and is specified as the working interface. The working interface is activated by default. To implement backup protection, add another physical serial interface to the SCADA group and specify it as the protection interface. Create a virtual serial interface and add it to the SCADA group. Use the virtual interface and the remote physical interface connected to the RTU to create a PWE3 service and bind the PWE3 service to the created SRv6 terminal. We also need to create the PWE3 service on the RS232 interface on duty 1. Check the PW state on duty 1 and duty 2. The PW state is up. After the service is up, use the RS232 serial port for communication on the PC. We have logged into their serial port on the PC. Enter a short message on the RTU. Check that the short message is correctly received on the remote master SCADA server. Simulate the failure of the master SCADA server by shutting down the interface connecting to the master interface. Manually activate the protection interface and perform a switchover through the command. Use the RTU to send the message again. Check that the backup SCADA server has received the message correctly. Check the statistics of RS232 interfaces on devices. There is no packet loss. That's all for the video about the P2MP SCADA service over SRv6. Thank you for watching.